Hello and welcome back to Apt for You. In this particular video, we are going to discuss a new problem from strings, and the problem is removing duplicates from the string, right? So let us quickly jump into the problem statement. So the problem statement says that we are provided with a string, and the task is to remove duplicates from the string, right? And one more important thing to keep in mind is that the original order of characters must be kept the same. So basically, we have to preserve the order in which the characters occur in the string, and we also have to remove the duplicates from the string. A good example, suppose I have a string s which is nothing but zvvo, right? So if you remove the duplicates from the string, what would happen? You can see z is present only once right here. V, okay, the first time v has appeared, write it here. V, this v, you see we have already written a v, so you don't have to write this v, ignore this. Go to o I haven't written yet, so you can just include this o in your string. So likewise, you can see you have completed the removal of duplicates from your string, and you have to basically return it. Similarly, if you focus on the next example, what you have is basically a string s is equal to gfg, and this is the first time I have encountered g, so I will write the g. This is the first time I encountered f, so I will write f. If you again consider the letter g, you have already encountered g, so basically you have to ignore that. So what are the letters that will be printed in the string after removing the duplicate? Only gf, right? So this is what we have to do, and we should better come up with a proper algorithm and approach to solve this particular problem. Some constraints to keep in mind: that the expected time complexity is order of the length of the string, right? You have to preserve this, you have to maintain this, right? You can't just increase the time complexity. Remember, order of the length of the string. It's alright, we can do that. Space complexity should be constant. Okay, we have to basically use a constant space which is independent of the size of the string. Okay, so let us try to implement this. The very first thing that I'm going to do is basically try to implement this using a constant space. Now if I have a string, then I can have maximum 256 different types of characters, right? Maximum 256 different types of characters in a string. So basically, for solving this particular problem, I am going to declare a map, suppose integer mp of 256. The size will be 256, right? And initially it is initialized. I'm just declaring it, right? So once I'm declaring this map, initially initialized to 0. So once I have declared this map 256, wherein each index in this map is going to point to a specific type of character, right? So whatever characters will be included in the string will be of one of these different types only, right? Now next thing is basically find the length of the string. So length of the string is s.length. Done. Now what we are going to do is basically traverse the string for I is equal to 0, I less than n, I plus plus. Got the point? So we are going to traverse the string from the left to the rightmost part, right? So suppose I have a string here as they had given the first string, suppose, what was it? ZVO, right? So ZVO, suppose this is my string. Alright, so suppose this is my string ZVO. So I am going to basically traverse the string from the starting to the last part. So 0, 1, 2, 3, n is equal to 4. So basically till less than 4 means till here. From here to here I have to just traverse it. So first time my I will point to this 0 location. What will I do? I will check if map of what s of I is equal to 0, means this haven't been included yet, means we haven't come across this particular letter yet. So if you haven't come across this particular letter yet, it indicates that this is your first visit and this is the first time you are encountering z. So basically I should also keep track of a variable index initially pointing to 0. So my I is also pointing here and index is also pointing to the same location. So s of index, what will I do? If I find that s of I is equal to 0, I'll say s of index is equal to what? S of I. Include that particular letter. So this is what I have to do. Yeah. So if s of I is equal to 0, so you can just see, let me just draw it more properly. So I have the letter z v v o. This is index 0, 1, 2 and 3. Right now my eye is pointing here and index is also pointing the same location. I found out that this is the first time I have basically visited z. So the corresponding status of z will be 0 in the map, right, in this particular array. So what will you say? You will say, okay, this is the first time I am seen z, so basically include z into the string. So basically as of that index, so as of this position will be equal to s of I, so z will be here, no problem, it's fine. Great. Now what should we do? Now you should also say increment the index to the next position. That is why I am writing index plus plus here. So now index will point to this position. Done. Okay, so now next time you come here, I will be pointing to this v, remember. So again I will check whether the status of this v in the array mp is 0 or 1. If it is 0, it indicates I haven't come across this letter yet, this is my first time I have seen v, so basically you should include it. So again s of index is equal to s of I, so again v will be included. Done. And index will be incremented. Next time you come here again in the loop, your eye will be pointing to this location, right? Your eye was there, now eye is pointing here, index is pointing here. So now you see that s of, if mp si is equal to 0, do you think it will be 0? No, because remember previously I have already converted mp of v as 1. I should convert it, right? So the moment you are including any letter, you should say mp of s of I equal to 1, means change its status to 1, which will indicate that yes, this has already been visited. So initially when I had visited v, I have changed the status of v to 1. So next time when you visit v, it will see that okay, it is no more 0. If it is no more 0, means you are not going to include it, ignore it. I will be incremented to this position. Remember index is still pointing to this position. Now at this position you will say, okay, what is the status of letter 0, letter o. Now letter o is also, this is the first time I have visited, so you will find it to be 0 only. So mp s of I will be equal to 0 only. Come inside, s of index is equal to s of I, so this position what you will include, this letter o. So letter o will come here, index plus plus, so index will come here. Got the point? And now you see you have already moved to come to the end of the array, the string array. Come to the end of the string. When you have come to end of the string, your index is pointing here, remember, and you have so far have z v o in your string. You should better fill null, right? All the remaining portions of the string should be better filled with null, right? So what should I do for that? Once you have completed this for loop, come outside, run a for loop again for I is equal to index and till the last position of the string, I less than n, I plus plus, right? What you should do, you should say s of I is equal to null, right? So I have just filled it with null, because remember right now my index was at the last point only, my index is pointing to last point only, because I am parallelly updating the same on the same string, right? So z v o I have already updated, but this last index I haven't updated anything, right? And the length of the string is 4, so basically this should fill with null. That is why from the index position where you had stopped till the last position you should fill it with null. Done. Now it should work fine. So what should be written basically? Obviously no doubt you should return the string s, right? So one more important thing to keep in mind is that I am using an integer array, right, wherein each particular index is going to point to a specific type of character, and now I am just saying mp of s of I. Now s of I is nothing but a character, so better I should use the ASCII value of that character. For that I'll be just using integer here, so that I can just convert its corresponding ASCII value. So I'll just write here integer s of I, that's it, nothing else, right? So what will happen, it will just take its corresponding ASCII value. This is the letter I'm pointing to, I'm taking its corresponding ASCII value, and in that particular location in the array mp I'm going to update the status, right? So I hope you understood this approach. Now this the reason why I am saying that the space complexity is constant, because you can see that I will always use the same amount of space for solving the problem, irrespective of the length of the string, because this is my constant, it is not changing with the length of the string, hence it is taking a constant space. Time complexity is definitely order of n in this case, because I am just doing one traversal of the string. Let us see if this code works fine. So Expecting I have not done any silly mistake anywhere. So this should definitely work fine. So return B, okay, this is a syntax, little error, spelling mistake. Alright, so yeah, this should work fine. So you can see the letter ZVVO, the string ZVVO has been reduced to ZVO, and it works fine, right? So the time complexity of this approach is order of n, and the space complexity is order of 1, because I have used a constant space, because every case, whatever be the length of the string, I'll always be using this, right? No more than that, no less than that. It remains constant. It remains constant, right? So another approach by which you can solve this particular problem is using Stl Unordered Map, right? How we can do it? Let me show you. Nothing different. Everything remains exactly same. Only 1 to 2 line changes in the same code. Let's see how. So remember, I am using here integer map, right? Instead of this, what will I use is basically unordered map, and that will be nothing but character comma, that will be character comma integer, suppose, right? And let me name it MP only. So I will have an unordered map that will have basically character comma integer, and in this case everything remains same. You don't have to use this integer here again and again, right? You can directly use s of I, no problem, because remember the first type is integer, a character, right? I've already declared here that the map will be of character comma integer, where character will be acting as the key and integer will be my value that will be keeping track of the status, whether that particular character is present in the string or not. Rest every working remains the same. You can just compile and submit it, it will work fine. But in this case, the time complexity remains order n, but the space complexity is no more order 1, because in this case the space complexity will also become order of n, right? Here the space complexity will also become order of n, and the time complexity will become order of n. So time complexity remains the same, but remember, in this particular approach the space complexity becomes order of n. You may refer this article on unordered map, you will understand it. Alright, so that's all from this video. I hope this video was helpful. In case of any doubt, please feel free to put it out in the comment section. Just like, share and subscribe. Thank you.